Good evening, viewers. Wishing you all a warm welcome to our fifth Tef podcast. As you all know, world over, the demand for electrical power is rising exponentially. In this regard, we have this topic today on the transition to digital substation in the power grid. My name is Sendil Kumar. I'm an electrical maintenance engineer working with KNPC's Mina Ahmedi Refinery. To throw light on this topic, we have with us an eminent electrical engineer, Mr. Satish. He's working with Siemens Kuwait and he is a commissioning engineer for protection and power utility communication. He has rich experience. Good evening, Satish.
Good evening, Mr. Senthil, and the viewers. I thank TEF 2025 committee for giving me this opportunity to share my insights on this topic.
Yes, Satish. Before we dwell into this topic, you have been in commissioning field for a long time. Can you share how this field fascinated you? How did you come to commissioning field?
I finished engineering in the year 1998 and then I joined a cogen plant. The capacity of the plant is 18.5 megawatt, which has a 110 kV switchyard. I was involved in the pre-commissioning, commissioning activities. Later, I joined a transformer industry where they are producing the transformers. There also, I was doing the testing and commissioning of the distribution transformers. After some couple of years, I joined generator protection control company where they are mainly focusing on protection relay testing services in UAE, and then I got an opportunity in UAE to do the testing and commissioning activities. There I am doing 11 kV switchgears, 130 kV switchgears. Then I was involved in the protection relay testings. Later I came to Kuwait in the year 2008 and I was joined directly with Siemens and doing this protection relay testing activities and mainly focusing on the device busbar protection. Later I was promoted as the head of customer service for the whole team and I'm managing all the execution projects throughout the Kuwait.
Thank you, Satish. We have a wide variety of audience from various backgrounds. For the benefit of the audience, can you explain what a substation is?
A substation is a facility in electrical power system that transforms voltage from high to low or vice versa. It plays a key role in the transmission and distribution of power. Substation typically includes transformers, circuit breakers, isolating switches, and bus bars which help and regulate the flow of electrical power. There are different types of substations such as step-up substations which increase the voltage from long distance transmission. This is mainly due to reduced transmission losses. Step-down substations which lower the voltage levels required by either industry or domestic consumers. Switching substations control and redirect the power flow without changing the voltage levels. In a nutshell, substation help to ensure electricity is transmitted efficiently and safely from power plant to the end users.
Thank you, Satish. You nicely explained what a substation is and what are its features. Can you throw light on what the electrical grid is, the electrical network system of any particular region?
Yes. Electrical grid consists of three major areas. One is power generation, transmission, and distribution. In the power generation, we produce the power from steam turbine or gas turbine and it is stepped up into a high voltage level and it is transmitted. The transmission substation will take the power from the generating area and it will go to the connected to the distributed stations. In the distribution transformers, where the voltage level is reduced from the high voltage from 132 kV to 11 kV, and from the 11 kV we have a ring main substations. It is connected to the domestic consumers or the industrial network. This is the overview of the power grid.
So now we have a good idea of what a substation is and what a grid is. Can we now dwell on what a digital substation is?
Yes. A digital substation is a modernized version of the traditional substation. As its name suggests, the digital substation brings digital technology into the heart of the substation. The digital substation focuses on digital both on station level and process level. By converting the analog data and binary status information from the substation. Digitalization provides a secure and reliable data transmission. The key features in the digital substation include smart sensors, communicating devices, and provide a real-time data on the voltage, current, and temperature of the devices present in the substation. Digital relays and protection devices that improve fault detection and isolation. Automation system that supports remote monitoring, control, decision making, cloud database storage, and analytics that help in predictive maintenance and optimization.
We have been working with substations for a long time. We are very comfortable with the existing substations. Why do we need to go towards digital substations? What are the benefits of a digital substation?
When we talk about digital substation, the main idea why the digital substation came into picture is decarbonization. When we talk about substation, lots and lots of cable are made up of coppers and they are using it for control circuits, protection circuits. To reduce the carbon footprint, we have to go to a different technology where we can achieve the decarbonization and improve the sustainability. When we go to the digital substation, one third of the copper used in the substation is reduced and all are converted into fiber optic. Okay, and no need to rely more on the copper resources, which will reduce your carbon footprint and improve the sustainability. This is the reason the digital substation came into the picture, and moreover, this is one part of the digital substation. The other thing is the very cost effective, reliable, and we get a real time data or all the equipments which is present, the assets which is present in the substation. That is the reason of this new technology. We are moving to digital substation from the legacy substation.
So, from what all you have explained on digital substation, it looks to be a very complex system. So, I think commissioning a digital substation should be a challenging task. Am I right?
Yeah, if you see in the beginning, the commissioning the digital substation, when you hear the new technology, whenever we hear a new technology, it seems to be a challenging task. Okay. When we go deep into the topic and when you analyze it properly, you will have a clear picture. And when you put some people and efforts of training, we can come to a conclusion that digital substation is more easier. The testing and commissioning methods will be very easy than a legacy substation. Okay, when we are used to it, the first project, if we execute with the digital substation, it will be looking complex for you. But when you are used to a technology, okay, it will be very useful for it. First time when you are using a smartphone also, you will feel it is not comfortable and you don't know, you have to remember everything in your mind, where to go, how to type everything, send like this, or using a WhatsApp. Okay, later now even the kids can do it because it becomes user friendly. Same way I can say in the beginning the digital substation will be very difficult for the users or the utility. Later, if they are used to it, it will be very easy to handle it.
Okay. We have hundreds and hundreds of substations all over the country. Are you insisting that we scrap all these substations and build a new digital substations?
No, that is not recommended. All the existing substations can be retrofitted to the new technology. In the sense, with the retrofit technology, we can upgrade the existing traditional substation to a digital substation. Only the few components in the secondary parts has to be changed. Say for example, now we are getting the measurements, pressure and temperature through analog devices. The portion where the analog devices are connected, there is a unit called merging unit. It's like a intelligent electric IEDs, like IEDs. So we will connect it, all the copper cables in the existing substation. We work on the secondary part, okay, and modernize the substation. And also there is no need to take a complete shutdown of the substation, bay by bay or zone by zone. It can be done. Okay, so before doing this retrofit solution, we have to make a residual life assessment of the substation. Okay, it is worthy of doing this upgradation, or we will go for completely building the new substation. Then it comes to all the budget and the project management team, and they have to decide whether they are going to upgrade the substation or they will build a new substation. Practically speaking, all the old substations which is built 50 years before also can be upgraded to a digital substation, keeping the primary parts as it is and putting the secondary modifications in the circuit.
Q. We are all familiar with commissioning of legacy substations. Does commissioning of digital substation pose any challenges? How different is it to commission a digital substation?
Whenever we talk about this word commissioning, commissioning means itself a difficult task. Either it is mechanical or electrical or communication. Commissioning means you are putting a device in the first time of the operation. So you will face lot of challenges. And the people who come for the commissioning is coming at the last. Okay, they are not involved from the design phases. Okay, they don't know anything from the design phases. And when there is a new technology in the market, and you want to do the things, earlier they are doing all the legacy substations where they are working with analog values and they are going to work with the communication protocols. Proper training on the subject and the engineering will do this task and they can able to carry out. But there are huge differences between legacy substation commissioning and digital substation commissioning. I agree with you, but it can be easily handled, and morely there it's like a software job, and all the communication protocols are verified in offline before entering to the substation. They can do their job and the substation can be easily commissioned.
Yeah. Now we have dwelled on what a digital substation is, what are its benefits. Are there any disadvantages with digital substations?
When we talk about the disadvantages with the digital substations, the vendor has to be selected correctly and there should not be any lock-in with the vendor. Okay, there will not be any proprietary protocols, and we have to go for a open source software like IEC 61850, in which all the vendors can use this, and also they have to think about the long term, okay, and the future upgradation and lifetime assessment has to be done. So based on this, they have to use the devices, and also for the future upgradation also to be considered in the beginning phase of the project. Okay, if all are considered correctly and they are using a open source software, and it's good to go for the digital substation.
Satish, from what you have explained, digital substations involve a lot of communication network. So are digital substations prone to cyber attacks?
Yes. To overcome these cyber attacks, okay, we have to follow the IEC standard 64423 in the project phase, and we have to make some many data security, which includes encryption, intrusion detection systems, secure communication protocols, security logging and monitoring, and adapting all to the communication protocols, which will definitely help in cyber security issues, and we can overcome these challenges with the following the standard protocols designed for the digital substation.
So from what you have explained, these digital substations involve a lot of specialized software. And do you think the present manpower available in the industry are skilled to handle this skill set?
Yes, once the concept is introduced, okay, there are skilled manpower people available in this concept, and they are doing their job well. But proper training has to be given to the people to bring more people in the picture, so they can definitely do more digital substation. And the technology is always concentrated in one region because of the skill sets are developed there. So the migration of these people to the different parts also is affecting, and where they are getting low manpower for the regions. Okay. And also the retirement of the people who is well versed with the technology, and the knowledge sharing has to be done in a proper way, so that the younger generation has take it to the next level, so that the manpower, skilled manpower for the technology will be reaching for our digital substation.
Okay. I will shifting to digital substations. lead to over dependence on specific manufacturers because there's going to use proprietary software. Further, there is going to be yearly renewal of license, patchworks, and other firmware updates. What do you think about this?
Yeah, to mitigate the issues mentioned by you, we have to adapt open standards like IEC 61850, which can help and mitigate the vendor lock-in by ensuring interoperability between devices from different manufacturers. Future proofing ensure that the chosen applications and the softwares will be enough for the future technologies and the addition of new devices. This will help you for vendor lock-in program, and you are safe for the entire life cycle of the project.
Okay. And generally, I found substations to be very safe. But again, in spite of so much advancements in electrical protection systems, time and again we hear about accidents taking place at various locations. Are digital substations prone to such accidents, or are they any better?
Any substations, okay, is it should have a safe working environment. Okay, I see the problem coming in the stations is arising from human error, which is due to their ignorance or overconfidence, and substation failures are happening due to equipment failure, due to aging or quality issues. These are all the two things which is causing accidents in the substations. Regardless of traditional substation or digital substations, this both can happen anytime, which can be improved by a proper training and putting more PPE and then following the safety procedures.
Okay. You would have come across many such incidents. Can you suggest what can be done to prevent such accidents?
In the electrical substation, we have to follow the safety rules. The major safety rules to be followed in electrical substation where we are working with the live part, isolate completely, verify for the absence of the voltage, proper lockout tagout, earthing and short circuiting, isolating the work area from the nearby live hazards. This has to be followed and the work has to be carried out, and later they have to use the correct PPE to ensure there will not be any accidents happen. Okay.
We have been working in substations for quite a long time, and operation maintenance have it's been going on very smoothly. But off late, there's a trend to use arc flash protection relays, arc flash protection PPEs. Do you think these are really required?
Yes, arc flash is the major topic actually in the electrical system. Okay, how we are doing a relay setting calculation, there is also they are doing arc flash. Whenever there is a discharge happening, they calculate what is the temperature it will come during the arc flash and what is the kilocalories produced, kilojoules. We call it as a kilojoules. Okay, accordingly, based on this, they will put the values on the sticker in the switchgear boards. So whenever we enter a live substation, whenever they are working in a live panel, they have to wear the 100% arc flash PP, okay, which will cover 100% of your body. Not even 1% of your body is exposed, okay. And according to the rating mentioned on the switchgear, we have to use this arc flash PP. So it is safe, reliable, and you are 100% safe when you are with the arc flash shoot. Even if you are not working inside the substation, you are going for a physical inspection or verification or taking the data with the high voltage components, and you have to use this and you have to take the data and we have to follow the safety procedures. Okay.
You have given a good idea about digital substations, legacy substations, the communication protocols. And we, in our audience, we have a lot of budding engineers who have just started their career. What is your advice or suggestion to them? How can they adapt to digital substations?
Okay. And there is a bright future for the young power engineers who is coming to this field. First of all, they have to be very strong in the fundamental. The fundamental is not going to change. Only the technology keeps on changing. Okay. The fundamentals is not going to change. And they have to attend many webinars, webinar trainings, online trainings, and a lot of videos about the technology is available from various manufacturers in the internet. And prior to the work, they have to make themselves ready and prepare themselves, and they have to work. They are going to work on the new technology, and they have to clarify all the doubts with the seniors until they are satisfied. Okay, until they are getting the correct answers, and they are good to go. Okay, I wish them good luck for all the young engineers.
We have a question from the audience. Off late, in most of the new substations, there's a new feature which is being introduced. It's called eSCADA, or ENMC, Electrical Network and Monitoring Control. Is it a part of the digital substation, or it's something different?
Yes, we can say it's a lower level of the digital substation. When we talk about eSCADA, only the minimum inputs are monitored. Say, for example, using the eSCADA, you will open the breaker, and get the data. Okay. When we talk about digital substation, eSCADA, the data are stopped in your station level itself, and it is not coming out of your complex. Okay. When we talk about digitalization, this data is available in the cloud from wherever you can operate. Okay, and you can see all the values. Say, for example, here all our digital signals from the beginning. Okay, so we put merging units, we put non-conventional instrument transformers instead of conventional transformers, and then we put lot of sensors. And we talk about switchgears, we put lot of sensors, and the sensor technology which is missing in the eSCADA. You will not have any sensors. Okay. So the real-time data like a conditioning monitoring is available in the digital substation, which is not covered in the eSCADA.
So digital substations are a better version.
Yeah, digital substation are the better version of the eSCADA, and it is the advanced technology. And the devices used here are completely a different platform. Okay, eSCADA will go in a different platform. Here the protocol used is IEC 61850, and the digitalization is the latest technology, and this technology will be there for another 30 to 50, 40 years technology.
As we've seen, substations are spread out geographically at different locations. And you are saying this concept of digital substation is the data is going to be coming to a particular control center. So how will you ensure that the data from the digital substation reaches the control center on real time?
On real time, yes. It comes all through the fiber optic network. Okay, there will be a well-established fiber optic network between the substations, not only for the digitalization. Actually, each substations are connected by a fiber optic network to transfer the protection data interface. Okay, when we talk a overhead line in a 400 kV substation, which is located two substations distance apart, say 100 kilometers, you will have a OHL line. Okay, and also we call OPGW, which is also running parallel on the top of the tower between these two substations. So these two substations are physically communicating and talking to each other, and some of the cores in this OPGW is used for our digital substation. So the data all are transferred, and it was collected through using the fiber optic network which is available in the existing network, and there is no need of additional cost to implement this. The data is transferred over the fiber optics, which is having an established connection between these stations.
Okay. And you mentioned about data. So earlier in eSCADA system, only specific data are being sent. Now in digital substations, huge quantity of data is going to be transmitted. How are we going to manage this huge quantity of data?
Yeah, this is a very important question. Actually, the data handling will be a very big difficult task in a digital substation. So the data has to be handled very correctly, properly, and we have to select the data which we need it. If you are adding a surplus amount of data which is not at all required for you, and then there will be a lot of issues will be coming. You will be overloading the system, say a process bus, all the technology will be the data, the real data which are all required. We have to select in the beginning itself, and you should not overload the data which is not required for this.
Okay, you mean to say that we should employ artificial intelligence so that we can collect valuable information from the data?
No, artificial intelligence is not involved here. But the design stage, we can say what are all the data to make ensure the reliable operation, what are all the data required from our past history. We know what data is required from the power system. Okay, maybe there will be a um, higher version. Okay, with the sensors and all, which we are not monitoring to make more real time data. We will get installing these sensors and get more data, but we have to be very careful also. We will not handle more data what is required.
So earlier we talked about cyber attacks, and we also mentioned that fiber optic cables are involved between the unit substation and the data. The data center or the control center. So if there is any cut in the fiber optic cable, or for any reasons the LAN system is not working, will the substation stop functioning?
Yeah. Actually, it is not communicating in one-to-one communication. The ring topology is installed. Okay, even if you lost, if you have a breakdown between two substations, the ring topology is there, and also some points they are using a mesh connection. Okay, as a redundancy, they can take out the substation through our surpass devices. And also as a third thing, they can also do a wireless communication with the GPS time synchronization. In that way also the data is transferred to the cloud. So options are there and no need to worry, and the data is secured. And even if you lose communication between 2 points, and there will not be a blackout happening. And especially when we talk about digital substation, the communication fail will not open any breakers. Only it will put away the signals. It knows it will go into a island mode. Okay, and it will do its own function what to do, and it's all pre-programmed devices, and it can be attended as a alarm. Okay, so no need to worry when you implement a digital substation and when a data is lost, and it will not cause any blackout until or unless there is a insulation failure or overloading of the lights. Only that will cause the power failure, but this will not cause a blackout, and there are many steps to mitigate these issues.
Okay. Thanks a lot, Satish, for spending time with us and sharing valuable insights on this topic. Now I'd like to welcome our committee member, Mr. Mani Arasu, to hand over a memento to you. Over to you, sir.